What is density and how do we solve problems pertaining to it? Well, let's jump right in with what density is. So if you've seen the equation before, then you know that density, and I'm going to use a lowercase d to represent it, is the mass of a thing divided by the volume of said thing. And the thing could be an object, it could be a substance, it could be a mixture. It really doesn't matter as long as you define it properly. So if I say, what's the density of a boat? Well, I just have to take the mass of that boat and divide it by the volume of that boat. And if I say, what's the density of water? I just have to take a mass of water and divide it by the volume that that mass occupies of water. Okay? So as long as we're talking about a specific thing and you just have the mass and volume that correspond to each other, you just take the mass divided by the volume and you have the density. And then it's just a matter of getting your units correct and things like that, and making sure that you have the correct mass and volume that correspond to each other. So let's jump right in with the problem. And we'll start off pretty simple here, and we're going to build up to a little more complicated, and then some different types of problems. All right, so let's jump in. So let's just say I have a problem, and I ask you, what is the density of a 5-gram object if it occupies 2.5 cubic centimeters of space? All right, so let's just write that down. I said, what is the density of a 5-gram object? And of course, grams is a measure of mass. And let's just say that I wrote 5.0 grams in the problem. So what's the mass of a 5.0 gram object if the volume that it occupies, or the space that it occupies, was 2.5 centimeters cubed? Now, let's just do a quick aside here and just talk about the units of volume, okay? So in the metric system, typically for liquids, you're going to see milliliters or liters, something with the base unit liter as your volume, okay? Right? You can have microliters, nanoliters, but anything with a liter as the base unit there is a volume. Now, if we use something like a centimeter, of course, a centimeter measures distance or length, right? So a centimeter, I'm going to make this larger, but let's just say that that's a centimeter. It's not, it's more, but the point is, let's call that a centimeter. And then what is a cubic centimeter? Well, if we first go back a step and say, what's a square centimeter? It's a centimeter by a centimeter. So if you have a centimeter in the left-right plane and then a centimeter in the vertical plane, that makes a square. And the area of a square is the side times the side. So it's 1 centimeter times 1 centimeter gives us a square centimeter, right? That's why you measure the area of a house. And at least in the States, we say square feet. In other places, it's going to be square meters, whatever it is, right? And now, if we add the third dimension of another centimeter, now we're talking depth. We're going in and out of the board. And so that makes a cube now. And this is not a perfect cube the way I drew it, but you get the idea. And so you have a centimeter by a centimeter by a centimeter, and that gives us a cubic centimeter. The volume of a cube is side times side times side, so it's a cubic centimeter. And coincidentally, if you take a cubic centimeter and you filled that with liquid, that is a milliliter. So a cubic centimeter is the standard unit to use on a lower scale for solids, and milliliters is going to be for liquids. But a milliliter and a cubic centimeter are essentially the same thing. It's just different ways of representing it, okay? So now let's jump back into the problem. I just wanted to teach you that on the side real quick because it confuses a lot of students. And so, by the way, if you see things with medication, you see cc's, or sometimes it's the volume of a motor or something like that, or an engine. cc stands for cubic centimeter, and that's just milliliters, okay? So let's get back into this here. So the question was, what's the density of an object with a mass of 5 grams that occupies 2.5 cubic centimeters of space? And of course, this is the easiest version of the problem because we just say that the density is the mass over the volume. So we're just going to divide it, right? So I'm going to say the density is the mass, which was 5.0 grams, divided by the 2.5 centimeters cubed volume. And that's going to give me, well, 5 over 2.5 is just 2. And these both have two significant figures. So I'm just going to write 2.0. And the unit is just whatever you see there. There's grams on the top, cubic centimeters on the bottom. We just leave the units the way that they're written. So it's grams per cubic centimeter. And that's the answer. That's the density. So when it's that straightforward, it's pretty straightforward. But now let's go to another step, okay? Or another level that's slightly more advanced here. And let's just say that you're given the density and you're being asked for either the mass or the volume, okay? Now, if you've seen my videos on dimensional analysis, or really anything like that, there's dimensional analysis like mole conversions, mass conversions, stoichiometry. I like to use the same technique every time. And I'm going to do the same thing now. And the reason I do this is because although, yes, there are tricks to do these calculations. There's a silly triangle, and if the things are on top or below each other or whatever, you do this mathematical operation. But if you memorize a trick for every single thing that you learn, you have to memorize a different trick for everything that you learn. But if you just understand a basic principle of how to cancel out your units, you can use that exact same method for many, many, many problems, not only in this course, but as you just go forward in life. I mean, I've used it all throughout all my science courses. I've used it to invent equations that I couldn't remember on an exam and got them right. I'm talking about dimensional analysis here. I've used them in my career as a product development engineer, as a quality manager. I've used dimensional analysis and just the process of canceling units in an equation my entire life, essentially, and ever since I figured out how to do it. And so I'm teaching that to you now, and I want you to use this method if you're going to continue here and learn with me. This is the way to do it, and I promise you it will make your life easier from now till forever. So let's get into it. So now, let's just say that I gave you a problem. I said the density of a material is 3.2 grams per milliliter. And I have 14 grams of the stuff. Okay, right? So I have 14 grams. So that means the mass is 14 grams. Let's just say it was 14.0 grams. And now I'm asking you, what volume does this occupy? So what is, or let's do it this way, V equals what? So what I always like to do is I always take the given information and put it to the left, or better phrased, the given quantity to the left. Now, I've been given two values. I've been given a density and I've been given a mass. Which one of these things is a quantity? In other words, an amount of stuff that you can hold in your hand, if your hands are big enough, right? So 14 grams of stuff, that's an amount of stuff. I can put 14 grams of that stuff in my hand. 3.2 grams per a milliliter, that's not a quantity. That's a trait, right? That's a intrinsic property of the material. It's a density. You can't hold a density. I can hold a mass of stuff. I can hold a volume of stuff. I can hold a certain amount of milliliters of liquid in my hands. I cannot hold a density. It doesn't mean anything because I could have a nanogram of the stuff or I could have a metric ton of the stuff. It'll have the same density, right? So I'm not going to put the density to the left. I'm always going to put either the mass or the volume to the left. And as we get to more advanced topics, you can put the moles to the left, right? Whatever it is. a quantity of things, the actual amount goes on the left side. And so I have 14.0 grams of whatever the stuff is. And then I set up a conversion factor, and my goal is always to cancel out the unit that I've been given and get the unit that I want at the end as my answer. And the way that we do that is whatever unit is here is going to go in the bottom so that it cancels, and whatever unit that we want is going to go on top so that it just ends up being on top as the unit that we end up with. And just to kind of explore this a bit further, when you have a fraction like this multiplying to something here, remember a number is the same as a number over 1. So this is the same as, and my marker's getting a little dry here, that's the same as this over 1. So anything on the top gets multiplied and anything on the bottom divides. Okay, so let's just say this was 2 and 3. I would do 14 times 2 divided by 3, okay? And that's why any unit that I put down here, if I put grams down there, it's going to be 14 grams times whatever this is divided by 3 grams. Grams on the bottom, grams on the top cancel out. So that's just a quick example. Now, how do we do the actual problem at hand, though? Well, if we look at the information that we have available to us, we have something that is a fraction or can go and be put in as a fraction. We have a density. A density is just a ratio between the mass and the volume of a thing, whatever we're talking about. And so I'm just going to rewrite this, not that I have to, but just to make it a little bit more clear what we're doing here. And I'm going to rewrite this as that there's 3.2 grams for every 1 milliliter of whatever this stuff is, right? This value, because it has 2 units in, can be rewritten as a ratio between those 2 units, right? If it's this many grams per milliliter, it's this many grams for every 1 milliliter. That's what that means. If you're driving at 50 miles per hour, you're driving 50 miles every single hour per 1 hour, okay? So we're going to rewrite this over here just as a little reference so that we know how to fill this parenthesis out. And now the thing is, I have grams up here. I know I want to cancel grams, and I want a volume, which is milliliters. So I'm going to take this density and I'm going to put it in whichever way it makes sense in order to cancel out the grams, which means the only way to fill it in is to put the grams on the bottom. So I'm going to put the 3.2 grams down here and the 1 milliliter up here, and then grams up here, grams down there, cancel. And now my answer is going to be in milliliters. And now I may do some things in my head, but I don't think I feel like doing 14 divided by 3.2 right now in my head. So let's not do that. Let's punch that in. And I'm just typing in 14 divided by 3.2. Anytime you're multiplying or dividing by 1, I just skip that. And so I get 4.375. I definitely knew that. So we have 4.375 milliliters. And of course, the final thing that we always have to do is check the significant figures, which, by the way, I have 2 different videos on that. So check them out. One is how do you do sig figs in the first place? And the other one is how do you do sig figs in a calculation? So check those out. But the point is, we have 3 sig figs here. We have 2 there. We have to use the lower quantity. So we need 2 sig figs in our final answer. That's infinitely precise. So 1, 2 sig figs. I'm going to round here. And I get 4.4 milliliters as my answer. So just to reiterate what we did here, they told us the density of the stuff. They told us the mass of the stuff that we actually have. This is how much you got. What volume of space does that occupy? And then we just said, okay, whatever the quantity of stuff that we have, we always put that on the left. There's the stuff. That's how much we have, 14 grams. And then in the parenthesis goes the relationship between the 2 units that we're interested in. So we had mass, we want to know volume. The relationship between mass and volume of a thing is its density. And so you don't have to rewrite it like this, but I find it useful, especially for students first learning this, just to visualize it. Instead of saying 3.2 grams per milliliter, to write 3.2 grams for every milliliter, or of course, that number will change depending on the density, okay? So now if I gave you volume and I asked for mass, right? If I gave you V and I wanted M, the problem would go exactly the same, and you wouldn't even have to think, oh, do I multiply by density? Do I divide by density? You don't even have to think about it at all. All you know is you put the quantity of stuff that you've been given on the left, and then make whatever that unit is cancel out. So what if this was milliliters? What if I had 14 milliliters and I wanted the grams? Well, I would just flip this upside down, because if milliliters are here, then they also have to go on the bottom to cancel out. And so in that case, if this was 14 milliliters, on the top would have been 3.2 grams, on the bottom would have been 1 milliliter, and then we would have just multiplied the 14 and the 3.2 across the top and gotten a different number, okay? So the point is, you don't have to memorize, oh, if I'm given mass, I have to divide by density. And if I'm given volume, I have to multiply by density. You don't have to memorize anything at all. Just understand how to cancel your units, and you cannot mess this up. And like I said, this may be 15% more effort. In my opinion, it's not, but some people find this slightly more laborious than just memorizing equations. I hate memorization, so to me, this is easier right off the jump. But even if you find this slightly more difficult, it will pay dividends as you go through more science courses, because if you're taking chemistry now, I'm sure you're going to have to do something else going forward in life, right? Most likely. You're going to have to take physics probably, or more advanced chemistry, or just in your daily life. Like I said, if you're a nurse, you're doing quantities of medications, it's good to understand how dimensional analysis and canceling your units works. So now, let's get to the other level of how these problems can go. So for this type of problem, we're going to bring it up a notch. And there's a bunch of ways I could ask this, but I think what I'm going to do is something like this. We're going to say we have a graduated cylinder, and it has 10 milliliters of water in it, okay? So we have, I'm going to just draw a little image here for us. I wish this marker was not quite as dry as it seems to be right now, but whatever. So we have a graduated cylinder, and there's some volume of water in it. Let's say it starts off at 10 milliliters, right? And so the whole question, let me just phrase this all off the top of my head here. You have a graduated cylinder with 10 milliliters of water in it. You drop a hunk of metal into it, and the volume increases up to 15 milliliters. The mass of the graduated cylinder and the water was initially 100 grams, and after dropping the mass of metal into it, it went up to 120 grams, okay? So I threw a lot at you here, right? There's a lot of numbers going on. Let me write them down, and hopefully I get the numbers that I just said correct, because I just made this up off the top of my head. So I'm pretty sure I said we have an initial volume of water was 10 milliliters, and I'm going to do 10.0 milliliters. And then we drop a hunk of metal in, and then the volume went up. I think I said it took up 5 milliliters, right? I think it went up to 15 milliliters. Pretty sure that's what I said. If not, that's the new problem. So the water, the level of the water, it was here. Then I drop a chunk into it, and then the water level went up higher by displacement, right? So if you get into a bathtub, the water level rises. That's displacement. That's what's happening here. So the initial level of water is 10 milliliters. We drop a chunk of stuff in there. it rose up to 15 milliliters. Hopefully that's what I said the first time, right? And then I also said that the initial mass of the graduated cylinder and the water was 100 grams. And so mass was 100, and let's do 0.0 grams. And then after dropping the chunk in there, I believe I said 120 grams. 120.0 grams. And like I said, if I somehow change the numbers slightly, this is just a new problem. So how the heck do we solve this, right? Density, by the way, the question is, what's the density of the thing that I dropped in? That's what we want to know. What's the density of the hunk of metal that you dropped into the graduated cylinder? And so we know that density is the mass of the thing over the volume of the thing. But I have 2 volumes and 2 masses. What numbers do I use, right? It looks crazy at first. But if we just take a break here and think about, we want the mass of the thing and the volume of the thing that we're concerned with. And so I said that this first volume was how much water we had. So that's just the water. We don't care about the volume of water. We want to know the volume of the thing. And so once I dropped the chunk of metal in there, the volume went up to 15 milliliters. So by displacement, clearly the object itself occupied 5 milliliters. So basically you just take whatever the second level was and subtract whatever the first level was, and that's the volume of the object that you dropped into the graduated cylinder, right? Just like when you get into the bathtub and the level goes up, whatever that first level was to the second level, that volume difference is the volume that you just displaced, okay? So then we know that the actual volume of the object is going to be the 15 minus the 10, so we have 5.0 milliliters. And then using the same exact idea, you weigh the water with the graduated cylinder, and then you weigh it again after dropping in this hunk of metal, and it went up by 20 grams. So just whatever the second mass is minus the first mass, that's the mass of the thing that you dropped in there, okay? So then the actual mass of the object is 20.0 grams. And now that we're here, is this a complicated problem anymore? No, right? Because they want the density, and density is just mass over volume. As long as, like I said, you have the mass of the thing that we're talking about and the volume of the thing that we're talking about. That's the only part of this that makes it more complicated, because you can get screwed up here and use the wrong volume or the wrong mass. But once you focus that it's the object that we're talking about, the hunk of metal, it's the difference of the volumes, the difference of the masses. And now that we have these, it's the same as the first thing that I taught you guys. So the density here is going to be the mass over volume, 20.0 grams over the 5.0 milliliters. And we get 20 over 5 is 4. So that is 4, but 2 sig figs, so 4.0, and that's grams per milliliter. And that's our answer. So guys, there's other versions that I could do, but basically the 3 types of problems that I showed you covers just about all the density problems you're going to see. Comment down below if you want to see any other things, or if you just want me to teach any other different topics. And please go ahead and give a like, follow, share, save this. Check me out over here to support me on Patreon. And by the way, thank you to my patrons for supporting me, and I'll see you guys in the next one.